So in this problem, we consider 3 tosses of a coin, and the 3 tosses are recorded, the results are recorded on 3 separate slips of paper, and these papers are put into a hat. So the first part, part A, says, what is the probability that all 3 tosses are heads, given that at least 2 were heads? So let's see what our sample space looks like after we learn the information that at least 2 tosses landed heads. So we could have heads, heads, heads. We could have tails, heads, heads. We could have heads, tails, heads. And we could have heads, heads, tails. Now, any one of these sequences is equally likely to have happened. So the probability that we have heads, 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 in other words, all 3 tosses landed on heads, is 1 out of 4. Now, in part B, we're told that we actually look at 2 of the slips, we turn them over, and we see that they say heads. So suppose we look at the slip of toss 1, so toss 1, and we see that it says heads, and we look at the slip for toss 3, and we see that it says heads. And now the question again says, what is the probability that all 3 tosses landed heads given this information? So what is this how does this information change our sample space? Well, now we know that the first toss was heads, so we have to have heads on the first toss, and we know that the third toss was heads, so we have to have heads on the third toss. So the only thing allowed to change is the outcome of the second toss. So we could either have a heads for the second toss, or we could have a tails for the second toss. And again, these 2 sequences are equally likely. We want the one where all 3 of them are heads, and so this probability is 1 over 2.